Hey guys, welcome to Deep Dive Machine Learning channel. I'm Yagesh Bobade, the founder of Deep Dive. This is an introductory tutorial where we will discuss what kind of problems we face in machine learning. So let's get started with the tutorial. What we'll be covering today? We'll cover topics like what is machine learning, what are the different types of machine learning, and mainly we'll be focusing on supervised and unsupervised machine learning problems. So let's start with what is machine learning. Machine learning as such doesn't have a formal definition, and you can also develop your own definitions when you understand it a bit better. But today we'll be discussing two main definitions that I think will give you a basic understanding about what exactly is machine learning. So first was given by Arthur Samuel. He described machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. He is considered a pioneer in the field of machine learning, and what he did was he created a AI checkers playing program. And what was fascinating was, at the start, the program didn't know how to play checkers, but as machines have patience to play thousands and thousands of games and gain experience with each game and get better at it, that's what the program did. And Arthur Samuel only had to write a source code and didn't have to write each and every game himself. So he didn't explicitly program it, but rather he trained, or rather, the model trained itself by playing games against itself, and with thousands and thousands of games, that model gained experience, and in the end, it was able to beat Arthur Samuel himself in the game of checkers. And these results were fascinating. Since then, research in the field of machine learning and artificial intelligence has exploded. Now, let's discuss a rather peculiar question. What exactly does learning imply in the case of a machine? Because learning itself is a process that we mainly associate with living beings, right? For this, let's discuss the second definition, which was given by Tom Mitchell. He says a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at tasks in T, as measured by P, improves with experience E. So let's discuss this definition with an example because it's kind of confusing to read it, right? What it says is, for example, if we have a task, in this case it is an image classification. So our task here, a task for the model, a task for the learning algorithm, a task for the program that we have to build is basically, if given an image, for example, if we give our program this image, now the program will tell, or rather we want it to tell, whether that image belongs to one of these categories, whether it's an airplane, automobile, bird, cat, deer, dog, frog, horse, ship, or truck. So that's basically the task for our learning algorithm. And now, initially, we have to provide this kind of data set. We have to provide already classified images to the model so that we can train on it, so that it can find patterns on its own, and in the future use those patterns to then make predictions. So this is basically experience, right? And then now we need a performance measure, right? We need to know how accurate our model is, and we also need to know whether the performance of that model is increasing or decreasing, whether the model is getting much better or whether it is getting worse with more data, which happens in some cases, all right, and we'll be discussing in further tutorials. So that is basically P. So now this definition says for a task T, if with experience performance increases, then it can be said as the computer program is learning. So that is basically what learning means when we talk about machine learning, right? Now if you did understand that, try to answer this question. If you have to create a program that separates the emails into spam and non-spam, then define task, performance, and experience. So basically, a spam classifier, right? So you have to define what is the task in this case, and what will be the performance measure, and what will be the experience. So that's basically what you have to do, and you can answer in the comment section. Now let's jump on to the next topic, types of machine learning. So types of machine learning include supervised machine learning, unsupervised machine learning, reinforcement machine learning, and there's also semi-supervised learning, and you'll also hear recommendation system learning algorithms. But mainly in this tutorial, we'll be discussing supervised and unsupervised machine learning, right? The basic concept about supervised and unsupervised is in supervised, you yourself train the model for a particular task. Unlike in this case, in unsupervised learning, the machine itself tries to find pattern without you doing anything. So now let's discuss supervised and unsupervised machine learning individually in a bit more detail. Let's start with supervised machine learning and let's discuss it with an example. For example, we have here a data set of house prices in Boston. So y-axis represents prices of houses in $1,000 and x-axis represents area of the houses in square feet. So when we give this to a learning algorithm, the learning algorithm might give us something like this line as a result. And sorry for the crude penmanship, but this is a straight line. And now if our model is given an input of say 1200 or 1300, whatever this is, 1200 square feet, our model might predict a value of around something like $260,000 in price. So this can be for one model, and if we use a more complex algorithm, we might expect a curve like this. So now we have something like a parabola, and this feels more accurate for house price prediction, right? So for the same 1200 square feet, now our model might predict some value of around $310,000, which seems more accurate looking at the data points, right? So depending on what we choose as our algorithm, we can have various kinds of complexities, we can have various kinds of accuracies in the model. Now, since we provided these yellow points, right, these can be the inputs. In supervised learning, basically, we provide these inputs to train the model, and these are basically correct answers, right? We already know that these are right answers, or rather, we already know the prices for these values. So we have to provide these correct answers in cases of supervised learning. And the problems in which we have to predict numerical values like the house price prediction, where we can predict 200,000 price, or the price as 250,000, 300,000, anything. So in such cases where we have to predict a numerical price, we call it as regression problem. All right. Now let's discuss another example. Here we have a data set which basically represents applicants with some years of experience and whether they got accepted or rejected for a job. So basically, from this data set, you can see that applicants with more than 10 years of experience mostly got accepted, and this guy here is an outlier. People like these, which are exception, like in this case, he has around 5 years of experience but still got accepted for the job, and such exceptions are called outliers in machine learning. And we see here the trend says that less than 5 years of experience, those people got rejected for the job. So when we provide this kind of data to a learning algorithm, we might expect our model to give something like this line as a result, and it can use this line to predict whether the applicant will get accepted or rejected. So if you have an applicant with, let's say, an experience of 13 years, so it lies at the right side of the line. So the model will predict that this applicant will get accepted. So this side is accepted, and if a point lies on the left side of the line, then our model will predict that the applicant will get rejected. So that's how we can expect the model to work. And the key point to notice here is that we only have two classes here, unlike the last problem that we discussed in which we have to predict numerical values. We in this case we only have to categorize whether the applicant gets accepted or rejected. So these kind of problems where we only have to categorize, we have to select a class, that are called classification problems. Let's summarize what we learned. In supervised machine learning, you yourself train a model to be able to make predictions, and you provide a data set which contains correct answers as we discussed as inputs. And in supervised machine learning, you face two kinds of problems. First, where you have to predict a numerical value, these are called regression problems. And second, where you have to predict or you have to categorize and you have to predict what kind of class the input belongs to. So these are the two types of problem in supervised machine learning. And in classification, we only discussed a problem with two classes that were accepted and rejected, but you can have multiple classes that can be 10, 100, more than 100, it can be anything. Now let's move on to the second type of machine learning, that is unsupervised. Actually, before that, try to answer these two questions. If you have to predict test score based on performance, if you have to predict whether it will rain or not, you try to tell whether these problems are regression problem or a classification problem. All right, and answer in the comment section. So now let's start with unsupervised machine learning. Unlike in supervised, in this you provide the data set, but you don't provide any kind of information about the data set, and you expect the machine or the model to find structures, find patterns in that data itself. So let's discuss this with an example. So earlier we discussed this example for classification problem, but if we have an unsupervised problem, then we'll have a data set like this. So we don't have any kind of information. We don't have x-axis, we don't have y-axis, we just have these data points, these random data points. And we expect our model to find structures, we find patterns in this data set itself. So if we give this data to an unsupervised learning algorithm, we might expect something like this. So it will find clusters or patterns in this data set. Now, in the future, if you have a point which lies here, so the learning model will predict that it belongs to this cluster. If you have a point which lies here, it will predict that it belongs to this cluster, and so on. So basically, this learning algorithm, this unsupervised learning algorithm, found patterns all by itself for a data set which didn't have any kind of information. And this is very useful, and this learning algorithm is called clustering learning algorithm. And this type of algorithm, these type of unsupervised learning problems have a wide variety of applications. For example, these can be used to organize computing clusters. It can be used for social network analysis. You must have heard mutual friends. You get like follow on Instagram. You have suggested followers, right? You have follow this guy, follow that guy, follow that guy. So that kind of thing, you use that and you can implement that by using clustering algorithms. In Google News, you use clustering algorithms to categorize one kind of news into same categories, like thousands of blogs are categorized into a single category by clustering algorithms. You can also use this for market segmentation. For example, this can be positive market sentiment, this can be neutral sentiment, this can be negative sentiment. So it is very useful in market analysis. And this case is astronomical data analysis. This unsupervised learning algorithm, clustering algorithm, has been very useful in astronomical data analysis because there are there is a lot of data in astronomical data analysis and not a lot of information about the data. So there, to find patterns, this clustering algorithm is very useful. Similarly, it has variety of applications in genomic study where you need it, and there are increasing uses for it to find gene clusters. So this is a interesting topic, and I would like you guys to research on it yourselves. This is time to conclude the tutorial, and if you liked it, please like, share, and subscribe. Thank you guys for watching, and see you guys next time.